Right now, while you're watching this, a part of your nervous system is performing a test on itself thousands of times a day, and almost nobody, including most doctors, is reading the results. It's happening in your eyes, specifically in how fast your pupils react when light hits them. Most people think of that as a basic reflex. Light goes in, pupil shrinks, end of story. But researchers studying brain aging have found something most people don't know. That reflex runs through one of the very first regions of the brain to show damage in Alzheimer's disease, sometimes 10, 15, even 20 years before a single memory problem shows up. Not before diagnosis, before symptoms exist at all. So the question this video is going to answer is simple. Can the speed of your pupil, not its color, not its size, but how quickly it reacts, actually tell you something about what's happening deep inside your brain right now, today? Stay with me, because by the end of this, you're going to understand a part of your own biology that almost no one explains correctly. And you're going to know exactly what to do with that information. I'm Dr. Thomas Ellison. I've spent the last decade plus in clinical practice, and if there's one pattern I've noticed in my older patients, the ones in their 50s, 60s, 70s, by the time someone fails a memory test in my office, the underlying changes in their brain didn't start that day. They started years, sometimes decades earlier. Quietly, underneath the surface while everything still looked normal. That gap between when the damage starts and when we can finally see it is the single biggest problem in preventing dementia, and it's exactly the gap we're going to talk about today. If you find evidence-based health information like this useful, consider subscribing. We're trying to reach 2,000 new people in this community by the end of the month. And every subscription genuinely helps more people see this before it's too late for them to act on it. Here's something most people have never been told. Your pupil is the only piece of your central nervous system you can actually see from the outside. Not a representation of it, not a symptom of it. It is nervous system tissue sitting in plain sight every time you look in a mirror. Think about what that means for a second. Your brain is locked inside bone. Doctors can't watch it work in real time without a hospital-grade scanner that costs thousands of dollars and takes an hour. But your pupil is wired directly through a genuine neural highway to some of the deepest, oldest control centers in your brain. The ones that regulate alertness, stress response, and attention. When light hits your eye, that signal doesn't just bounce back lazily, it races down this highway to brainstem structures that have been managing survival functions since before you could form a single memory. And then a response comes back, telling the muscles in your iris exactly how fast and how far to close. That round trip happens in a fraction of a second. And here's the part almost nobody explains. The speed of that round trip isn't just a reflex test, it's closer to a live data stream, a real-time readout of how well certain critical brain circuits are firing in. So when a pupil reacts instantly, sharply, snapping shut the moment light appears, that's a circuit working exactly as designed. When it reacts slowly, sluggishly, almost reluctantly, that's not random. That's information. And that brings us to the part of the brain actually responsible for this, because there's one structure in particular that researchers keep coming back to, and it might be the most important brain, the region you've never heard of. It's called the locus coeruleus. Say it with me, locus coeruleus. I promise this is the last intimidating term in this video, and once you understand it, you'll never forget it. Here's the simple version. Deep in your brainstem, there's a tiny cluster of cells, smaller than a grain of rice, that acts like the central alarm dispatcher for your entire brain. It produces a chemical called norepinephrine, which is your brain's pay attention, something's happening signal. Every time you wake up fully, snap to alertness, react to a sudden noise, or focus hard on something. That little cluster is involved. Think of it like the breaker box for a house. You don't see it, you don't think about it, but every light, every appliance, every signal in the house runs through it first. If the breaker box starts failing, you don't necessarily lose all the lights at once. You might just notice a flicker here, a dim bulb there, long before anything goes fully dark. Here is a discovery that changes everything. Postmortem brain studies have found that this tiny alarm dispatcher region is consistently among the very first places in the entire brain where a toxic protein called tau begins to accumulate in people who go on to develop Alzheimer's disease. Tau pathology has been identified as the earliest occurring biomarker for Alzheimer's, with research consistently showing it first appears in the locus coeruleus. Read that again, not the memory center, not the hippocampus, the part everyone associates with memory loss, the alarm dispatcher, the part that controls alertness and reaction speed, appears to be hit first, often decades before a single memory symptom appears. And remember what we just said about the pupil. That same alarm dispatcher region is one of the key regulators feeding into the pupil's light reflex. So, when researchers measure the speed of someone's pupil response, they may be capturing indirectly a kind of stress test on that exact same vulnerable region. The pupillary light reflex is primarily controlled by a nucleus that receives modulatory input from the locus coeruleus, located just beneath it in the brainstem. A sluggish pupil, in other words, may not just mean you're tired or the lighting is dim. In a small but growing body of research, it may be one of the earliest physical echoes of cellular wear happening in that alarm center minus years before it's loud enough to cause a symptom you'd notice in daily life. That's the unexpected discovery. Your eye isn't just near the brain. In this very specific, very real way, it's reporting on it. Now, and this is important, a slow pupil reaction on its own does not mean you have dementia. It does not mean decline is guaranteed. What it means is that scientists have found a measurable physical signal connected to a process that, in some people, unfolds over many years, and that signal is detectable long before the tools we currently rely on in clinics can pick anything up. Which raises an obvious question. If the signal exists, why isn't your doctor already checking it? Let me tell you about a patient I'll call Margaret, 68 years old, recently retired after 30 years as a high school librarian. Sharp, organized, the kind of patient who shows up with a typed list of questions. Margaret came in worried about feeling a little foggy. Nothing dramatic, just a sense that she had to concentrate harder than she used to. I did what most physicians would do, a standard cognitive screening, word recall, orientation questions, simple drawing tasks. She passed comfortably. And under the old way of thinking, that would have been the end of the conversation. You're fine, Margaret. Come back if it gets worse. Here's the problem with that. Standard memory and cognition tests are built to catch damage once it's already large enough to disrupt daily function. By the time someone fails one of those tests, research has shown that significant brain tissue and connectivity may already be affected. The test isn't catching the beginning of the process, it's catching the consequences of a process that's been running for years. Cognitively normal elderly individuals with underlying Alzheimer's pathology can remain asymptomatic for decades, making early detection through traditional symptom-based screening extremely difficult. That's the real tragedy in dementia care. We built our entire early warning system around catching smoke after the fire's already spread to several rooms of the house. This is exactly why pupillometry, the measurement of pupil response, has researchers genuinely excited. In one longitudinal study tracking pupil response over time in people with early cognitive concerns, researchers found that a smaller resting pupil diameter was associated with more than 4 times the risk of measurable clinical progression over the following year. A decrease in resting pupillary diameter was associated with a higher risk of clinically evaluated progression with an odds ratio of 4.3. Now, I want to be precise here, because overselling the science does nobody any favors. This is not a perfect crystal ball. The predictive accuracy in these studies is described by researchers as moderate, not definitive, meaningfully better than guessing, but not yet a standalone diagnostic tool. Researchers are still working to bring this technology from research labs into everyday clinical use. This research is intended to help guide future efforts in bridging the gap between developing digital biomarkers and actually implementing them in clinical care for early Alzheimer's detection. But think about what that gap represents: a measurable physical signal years ahead of a symptom-based test using nothing more than a brief light shown into the eye. That's not science fiction. That's published research happening right now. So if this is real, why haven't most people heard of it? Partly because turning interesting research finding into tools sitting in your doctor's office takes years, but also because, until very recently, the equipment to measure this precisely required specialized clinical devices. That's starting to change. And what's changing, it might already be sitting in your pocket. Here's where this gets genuinely interesting for you. Watching this at home, engineering teams, including researchers at institutions like UC San Diego, have been developing smartphone-based systems that use a phone's built-in cameras to track pupil changes with a level of precision that used to require a dedicated clinical pupillometer. The technology uses a smartphone's built-in near-infrared camera along with a regular selfie camera to track how a person's pupil changes in size, with these measurements potentially used to assess cognitive condition. And this isn't a one-off lab experiment. Researchers have specifically continued this work with an eye toward older adults. The research team has planned future studies working with older individuals with mild cognitive impairment to test smartphone-based pupil tracking as a risk screening tool for early-stage Alzheimer's disease. Now, I want to set realistic expectations here, because this is where a lot of health content online overpromises. This technology is still primarily in research settings, not something I'd tell you to rely on as a home diagnostic tool. Today, clinical-grade pupillometers, the kind used in published studies, remain the gold standard for now, but the direction of travel is unmistakable. Pupil-based screening is moving out of specialized neurology clinics and toward something far more accessible. So what would researchers actually be looking for? If you could measure this precisely, a few key markers separate what's typically described as a healthy response from a higher risk one. First, latency, how long it takes the pupil to even begin reacting once light appears. A healthy response begins almost instantly. A delayed onset is one of the patterns researchers flag. Second, constriction velocity, minus the pupil starts shrinking. How quickly does it get there? A snappy, efficient constriction reflects a well-functioning circuit. A slow, Gradual narrowing is the pattern associated with the sluggish responses we discussed earlier. And third, resting pupil size, which, as we covered with Margaret's situation, has its own independent association with risk when it trends smaller over time. None of these numbers mean anything as a single snapshot. The real value researchers are working toward is establishing your own personal baseline, what's normal for you, and then watching for meaningful drift away from that baseline over months and years. That's a fundamentally different approach than today's system where you wait for a problem and then get tested once. It's less like a single photograph and more like a slow-motion video of your own brain health, one frame added every year of monitoring. So if the tools to measure this with precision are still emerging, what can you actually do with this information today? This is the part I think matters most, because awareness without action just creates anxiety. Let's fix that. I want to introduce you to one more patient, a man I'll call Walter, a retired civil engineer in his early 70s. Walter didn't come to me because of memory concerns. He came in because his wife mentioned, almost as an aside, that he seemed to react slower to things lately, not physically, just generally, a beat slower to respond in conversation, a beat slower getting going in the morning. We talked about his sleep, 5, sometimes 4 hours a night, for years, because I never needed much sleep, a phrase I hear constantly from men his age, and one I've learned to take seriously as a red flag rather than a brag. Here's why that matters directly to everything we've discussed. The locus coeruleus, that tiny alarm dispatcher region, is heavily involved in regulating your sleep-wake cycle, and deep sleep appears to be one of the windows during which the brain clears out metabolic waste, including the very tau protein we talked about earlier, accumulating in that region. Chronically shortchanging sleep doesn't just make you tired, it may be removing the daily maintenance window, that region. Depends on. So the first, most immediately actionable thing isn't exotic, it's protecting genuine, consistent, deep sleep. Not I get by on 6 hours, but actually prioritizing 7 to 8 hours with a consistent schedule. I told Walter this bluntly. Of everything we discussed that day, fixing his sleep was the single highest leverage change available to him. Second, vascular health. The blood vessels feeding the brainstem are small and unforgiving. Years of unmanaged blood pressure or blood sugar create the kind of microscopic vascular damage that researchers have found correlates with abnormal pupil responses, sometimes even more pronounced than the changes seen from Alzheimer's pathology alone. Subtle cerebrovascular damage has been linked to aberrant pupillary responses, with one study suggesting vascular cognitive dysfunction shows even more pronounced effects on pupil response than Alzheimer's disease itself. In plain terms, keeping your blood pressure and blood sugar in healthy ranges isn't just protecting your heart, it's protecting this exact alarm system we've spent the whole video discussing. Third, and this is the frontier I find most exciting as a physician, researchers are actively investigating ways to support the brain's own waste clearance systems once early dysfunction is detected. Rather than waiting for irreversible decline, this is an active area of ongoing clinical research, not yet a settled, prescribable treatment, but the direction is hopeful. The goal isn't managing decline after the fact. It's intervening upstream while the alarm system is still mostly intact before the damage compounds. I want to be very clear about something before we close this out. None of this, not pupil speed, not sleep, not blood pressure, is a diagnosis. It's not a verdict. Think of it the way you'd think of a smoke detector with a low way. Battery warning. It's not telling you the house is on fire. It's telling you that now is the moment to check things while you still have every option available to you. Here's what I want you to walk away with. For most of medical history, the brain has been a black box, something we could only really evaluate once damage was severe enough to show up in behavior or memory. That era is ending slowly, imperfectly, but undeniably. The fact that something as simple as how quickly your pupil reacts to light might carry a whisper of information about deep brain health years before any other tool could tell you isn't frightening. It's an opportunity that didn't exist for any previous generation of older adults. Margaret is still doing well, by the way. Walter's sleep is dramatically better, and so he tells me is his thinking. Neither of them got a scary diagnosis that day. What they got was an early nudge, months or years sooner than they otherwise would have minused toward changes that mattered. That's the entire point of paying attention to signals like this one, not fear time. If this helped you understand something about your own health that you didn't know walking in, do me a favor and hit subscribe. Our community is working toward 2,000 new members this month. And the more of us paying attention to research like this, the more pressure there is on the medical system to bring these tools into everyday checkups faster. Drop a comment and let me know. Had you ever heard of the Locus Coeruleus before today? I read every one of them, and the questions you ask shape exactly what I cover next. And if someone in your life has been brushing off feeling a little slower lately, send them this video. Sometimes the most caring thing you can do is hand someone information a few years before they'd find it on their own. I'll see you in the next one. And